From the top of a cliff 112 meters high, the angle of depression to a boat is 9 degrees. How far is the boat from the foot of the cliff? So here we have a depression problem, and with depression and elevation problems, the first step is to always try and draw a diagram. So let's go ahead and do that. Now the first part says that the cliff is 112 meters high, so let's go ahead and represent that. So I'll just draw a cliff, and we'll make that 112 meters high. Generally with elevation and depression problems, you're trying to draw a triangle, so don't put any extra features in that you don't need, just draw lines. Alright, now it says the angle of depression to a boat is 9 degrees. So from the top of the cliff, I'm going to draw another straight line all the way down to the bottom, and that's going to be the line from the top of the cliff to the boat. So here's my boat, and here's the top of cliff. Okay. Now it says the angle of depression to the boat is 9 degrees. Whenever you are asked to draw or describe an angle of depression, you always must draw a horizontal line. So let's draw a horizontal line. I'll use a green stylus here, and from the top of the cliff, I'm going to draw a horizontal line. Let's go ahead and fix that up. Alright, from the top of the cliff, I've drawn a horizontal line. Now, that is where you start drawing your angle of 9 degrees. So, in here, that is where, let me use my normal stylus, that's where you draw your 9 degrees in. Because it's always from the horizontal plane. The remaining angle, all of this, must add up with 9 degrees to make 90, because obviously we have a right angle here. So that must be 81 degrees here. Alright, now it says how far is the boat, so here's the boat, how far is this boat from the foot of the cliff? So if you draw a straight line in between the foot of the cliff and the boat, as you can see, you've got a right angle triangle there. So here's my right angle triangle. Here, 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 and here. So with a right angle triangle, with an internal angle and a side, we can use a trigonometric ratio to figure out the distance between the boat and the foot of the cliff. And we'll call that x for now. Okay, so with our internal angle, we know the adjacent side, so that's the adjacent, and we know the opposite side, that's x. Well, apologies, we don't know the opposite side, that's what we're going to try and find out. So we can write a trigonometric ratio for this problem here, and if we're going to be using the opposite side and the adjacent side, immediately you should be thinking of the tangent of the angle that we have, the tangent. Now in other words, we could just write tan, and that's what we'll work with today. So the tan of 81 degrees is equal to the opposite side of the angle divided by the adjacent side. Okay, from here I'm going to substitute what we know about the opposite side and what we know about the adjacent side. Let's go ahead and do that. So tan 81 equals, now opposite is x, and adjacent, excuse me, the adjacent is 112 meters. Alright, from here, I want to move 112, I want to move that to the other side of my equation, and in doing so, I reverse the operation that's currently being applied to 112. Currently, 112 is being divided. If I move it to the other side, it'll become multiplied. So let's rewrite that. Tan 81 multiplied by 112 equals x. And then you can put tan of 81 multiplied by 112 into the calculator, and x equals 90.8 meters.